All right, good morning, everyone. Welcome. Again, it's good to see some familiar faces as well as some new names. We're really happy to be here to present the findings from our Global Temperature Report for 2025. I'm Kristen Sissener, Executive Director of Berkeley Earth, and joining me on the call this morning is Robert Rohde, our Chief Scientist. We also have Zeke Housefather, our Research Scientist, and would like to thank Kate Viscara as well for making sure all of this runs perfectly behind the scenes and putting everything together for us. So before we get into the report itself, we just have a couple quick introductory points to share. So next slide, Robert. So just a couple quick notes about Berkeley Earth, if you're not familiar with our work. Berkeley Earth is an independent climate science and climate monitoring organization. We are ostensibly based in Berkeley, but we are a global organization, and we are dedicated to producing independent and transparent and open climate data and analysis. We are funded entirely through philanthropic grants and independent support. We do have a modest amount of essentially commercial revenue from our partnerships with our commercial partners, but our funding is entirely independent of federal funding sources. Next slide. The analysis that you're going to see today in the presentation is made using Berkeley Earth's own high resolution surface temperature data set. So there's some information there on the slide about this product. We offer a quarter degree resolution with global coverage. We do provide off-the-shelf subsets for more than 8,000 global cities, as well as providing, again, off-the-shelf national TMIN and TMAX subsets as well. We do provide custom subsetting, custom products, should that be helpful as well. And this product is currently updated on a monthly cadence. There's a QR code there if you want to go ahead and request access to that. This is currently available by request for now. I think Kate also just popped a link into the chat as well, so that's available. And then next slide. We're offering a few statistics on this product and what it really takes to build an observational surface temperature data product like Berkeley Earth's high-res product. So we don't often share these kind of statistics and details about this product, but they've become somewhat relevant this year in context that Robert's going to discuss briefly. But we wanted to just highlight a couple of the interesting statistics that we think go into producing this product. So worth mentioning that the approach we take with producing this product allows us to maintain the largest archive of any of the global monitoring groups. And that is something that we are currently actively in the process of expanding. And I'm going to go ahead and pass to Robert to discuss a little bit more of the details behind this product and what we're working on going forwards.
Okay, so good morning, everyone, or afternoon, or wherever you may be. So as Kristen said, we build a surface temperature project using observations, so thermometer measurements at weather stations and from ships and buoys in the ocean. As you can see on the screen, there's it takes millions and millions of measurements to build the data sets we work with. We currently have the largest archive of weather station data from any of the groups by about a factor of 2. In 2025, we added about 7,000 new stations to our collection, mainly by incorporating 2 data sets that were HCLIME, which is a early instrumental data set, mostly 18th and 19th century data. So it includes our early representation, and by adding in ECAD, which is a European-based data set that is daily as well as monthly data, and it says Europe and also some of Asia. We've expanded our efforts to collect near real-time data from the WMO Information System 2, from GCOS, and from other sources to build additional resiliency and access to greater data sets. One of the reasons we've done this in 2025 is that we've been challenged by ongoing operational deficits at NOAA. Since August, NOAA has had uh, data sets which are either incomplete or completely inoperable due to what I am led to understand is computer system upgrades that did not function as intended. And they have been working to resolve these issues, but it has been going on for months. The map shown at left notes places where the GHGN monthly, which is NOAA's main climate monitoring system, was missing stations, which are shown in red. This particular map is for November, but you can get similar maps for December and for other months. Uh, is my understanding is that NOAA is working to fix these issues and that they should eventually be resolved, but we don't know the timeline for that. We are also currently raising funds to develop alternative data aggregation that doesn't rely on NOAA. NOAA has been in this role for decades, where they are gathering data from I believe it's about 160 national and regional partners around the world, and aggregating that data to provide to researchers, which is a fantastic service they've been providing. But as we've seen this year, when things fall down, it does impact the availability of data for us and for others. Okay, so preliminaries away. Let's talk about
Before
2025. Ah,
I'm gonna pause you right there, Robert, really quick. Just a quick housekeeping note. We are taking questions. We will open up for Q&A after the end of the presentation, and we've allowed extra time this month relative to our normal monthly updates. So if you do have questions as we go through the presentation, please feel free to pop them in the chat box. We will start addressing those after the presentation. And also just a quick note, we are recording this, and we will be sending out a recording after the presentation. Final note, the report is currently live. I'll ask Kate to go ahead and pop the link in the chat. So you should have access to that as well. And Robert, I'll go ahead and pass back to you.
yeah. And the report online will have all of these figures and information, as well as additional things that we won't cover in the live briefing. So 2025 was the third warmest year in our data set. It's the third warmest year in most of the analysis data sets. 1.44 plus or minus 0.09 C, or 2.6 plus or minus 0.17 Fahrenheit, above our estimate of the 1850 to 1900 average. It's somewhat cooler than 2023 and 2024, but much warmer than any year prior to 2023. And the last 3 years have all been in this very warm state. Shown here with both the value and its uncertainty, shown as sort of a probability diagram. You can see that 2025 overlaps considerably with 2023. There's a question about whether you would describe this as effectively tied or not. Some people prefer saying that this level of overlap is tied. It is nominally the third warmest year. It could also be described as tied for second place. And as noted, the measurements and the uncertainties for the last 3 years cluster well above the period before that. Now for the seasonal evolution of temperatures in 2025. We opened with record warmth in January and March. That was followed by cooling, and then most of the rest of the year followed below the 2023 and 2024 averages. So it started quite hot, but then cooled to be a little bit below the record years. 2025 had widespread warmth nearly everywhere, as we've come to expect from global warming, with substantial warmth in North America, Asia, South America, Africa, as well as significant warming events in the Northern Pacific, the North Atlantic, and a bit around the Southern Ocean. There were no areas of significant cooling relative to long-term averages in 2025. In looking at where we had local temperature records, indicated here by the darkest red, we find that 9% of our surface was locally record warm in their annual average in 2025, 10.6% of land, 8.3% of oceans. This corresponds to record. This we estimate that this caused record national averages for the year in about 16 countries. This is far fewer than last year, when in 2024 the record was, more than 100 countries were setting a record. But that's where we expect a step down. It's not as extreme. The people who are living in the darkest red areas amount to about 770 million people. Most of those locations are coming out of Asia, with China by itself contributing about 450 million people due to the warming in the highly populated area of eastern China. Other places significant were Pakistan, Uzbekistan, Tajikistan, a bit on the coast of South Africa, and a bit on the UK as well, in terms of populations affected. Land average temperatures were nominally the second warmest in 2025, effectively tied with 2023. This is the third year in a row that temperatures have been at least 2 degrees Celsius above the pre-industrial baseline in the land average. On the oceans, it was distinctly the third warmest year, cooling quite a bit from the El Nino boosted warmth of 2023 and 2024, but still only the third year with a temperature above 1.0 Celsius from the baseline. Now, we want to talk about the context of 2023 and 2024 and 2025 together a little bit. This 3-year period has been quite exceptional. It sticks up well above what we would have expected from a linear continuation of ongoing warming. If you look at the 50-year period prior to this, you have an almost linear growth in temperature. And the last few years have diverged from that. And this level of divergence, if it were to be explained by natural variability, things like El Nino alone, would be a roughly 1 in a 100-year event or less, which is possible. But when you see an event like this, the alternative is that there are other factors at play. And we think from the evidence that there is other factors contributing to the recent warming and giving us a bump up beyond what we would have expected from the recent historical trends. The explanation for this bump up does not appear to be greenhouse gases by itself. Greenhouse gas warming has continued a roughly linear progression over the last 50 years, and temperatures have risen more or less in step with that, whereas the last few years have deviated upwards. And that leads us to look at other potential factors for recent warmth. One factor that has gained a lot of attention recently is increased absorption of solar radiation. So this is measured by NASA satellites. They look at how much sunlight is reaching the Earth, how much is getting reflected back into space, and they can measure how much is absorbed. And they can similarly measure how much thermal radiation is coming off the Earth. The imbalance between what is absorbed and what is radiated away is the cause of warming. And the change in absorbed solar radiation is largely due to decreases in low cloud cover, allowing more sunlight to be absorbed at Earth's surface. And the explanations for that, we'll talk a little bit about plausible explanations for that in a moment, but that is the likely an effect that is contributing a bit to extra warming in recent years. Now, this plot summarizes sort of a rough understanding of factors contributing to temperature fluctuations over the last 10 years. The main cause of long-term warming is the rise in greenhouse gases, indicated by the first panel over on the left. You're getting a rise of a bit more than 0.2 C a decade, just from the greenhouse gas contribution. On top of that, you have internal variability, such as the El Nino and La Nina cycle, which gives rise to short-term fluctuations in global mean temperature. And you also have predictable changes in the sun itself, where there are small fluctuations in the amount of radiation provided by the sun. Beyond that, there are two unusual events that have occurred in the last 5 years that we would call attention to as possible explanations for the deviations we're seeing above the sort of the expected trend. Uh, One of those, which is almost certainly a contributor, though there's some debate about how much of one, is the reduction in marine sulfur air pollution that has occurred over the last 5 years. This is essentially an accidental experiment in geoengineering, where in the year 2020, new international rules took effect, known as IMO 2020, which cut the allowable sulfur content in marine shipping fuels. And overnight, this reduced the marine sulfur pollution in the air by about 80 to 85%. That sulfur air pollution has the effect of reflecting sunlight and increasing cloud formation. And as a result, removing the sulfur air pollution would allow more sunlight to be absorbed and potentially increase the rate of warming, especially in the regions in the North Pacific and North Atlantic, where you have the biggest contribution for marine shipping. So the places where you had the most sulfur to begin with. The exact magnitude of this effect is somewhat debated, but it almost certainly has contributed a bit to the recent warming. The other factor, which is more uncertain, is the Hunga eruption of January 2022. This was one of the most explosive eruptions we've seen in over a century, and it had a highly unusual characteristics in that it was relatively sulfur poor and unusually water vapor rich. Water vapor has a warming effect, sulfur has a cooling effect. Most of the time, when you have a large eruption, the sulfur is so large that you just get a cooling effect, and there's no concern about potential warming at all. But Hunga Tonga, when it erupted, injected about 150 million tons of water into the stratosphere, increased the water vapor content of the upper atmosphere by about 15%. And the evolution of this is that this sulfur tends to dissipate first, dissipates more quickly, and the water vapor dissipates more slowly. So despite it being, 4 years later, we still have about 50% of the water vapor in the upper atmosphere. The question mark is what effect does this all have? A recent modeling study, which I'm highlighting here, actually estimated that the sulfur emissions provided cooling initially, and that the water vapor effects, both direct and dynamical, can potentially produce warming afterwards. And however, these are uncertain estimates. Some people suggest there could be warming right away. Other people suggest there may only have been effectively cooling from this. So we're not really sure about the impact of this, but there's a plausible argument that it has contributed to recent variations, and it is something that people are continuing to study and understand.
Yeah. On that, it's also important to emphasize that the magnitude of the estimated effect is still modest. We're talking about 0.05 of a degree C. So it's a contributing factor, but not the explanation for the bulk of the anomalous warming.
Yes, I would say that's absolutely true. It's a factor additional to the other ones. Okay, turning a little bit now to the future. So I'm highlighting here the monthly changes in ocean average temperature. We've been on a declining monthly trend in ocean averages since the peak of the El Nino-related warmth in 2023. And in 2025, we actually slipped into, we had a La Nina, an ocean cooling event at the start of the year, we went to a neutral condition, and then we slipped back into a La Nina cooling event at the end of the year. And while we have formally had those La Nina events, we have not dipped down as cool as we might have expected for a La Nina event in the oceans so far. As I just said, we had the large, significant El Nino event 2023, 2024, which contributed to record warmth. And then we dipped down to a weak La Nina at the start of the year, briefly rounded above the La Nina threshold, causing neutral conditions in the middle of the year, and have now had a second dip back into La Nina conditions. This likely serves to keep 2025 annual averages a bit cooler than the other recent years. We are anticipating that the ocean conditions will return to neutral early in 2026, and a new El Nino event is possible in mid to late 2026. It's sort of a coin flip at this point, so we may transition to a warmer state by the end of next year, but we will have to wait and see. Looking ahead to 2026, right now our forecast puts it as likely similar to 2025 with a significant uncertainty range. There is a 10% chance that it could warm enough to become the warmest year, but a 50% chance that it's likely to be the fourth warmest year or somewhere in that ballpark. So the most likely outcome is that we stay close to where we were and don't do anything exceptional in 2026, but it will depend on how factors like potential El Ninos play out. The earlier in the year an El Nino develops, the potentially more impactful it would be on 2026. If it is typical, it comes near the end of the year, El Nino related warmth would have a larger effect on 2027 than it would 2026. So we will see how that plays out. And this now is, instead of doing the annual averages, this is the 12-month moving average. And the real question is what comes next? Are we talking about a short-term bump that causes a little bit of deflection in the trend, or are we talking about an accelerated trend over the long term? The exceptional warmth of 2023 to 2025 is clearly a bump up, a deviation from expected trends. If it is primarily due to factors like Hunga Tonga and reduced shipping sulfur, this could be a short-term bump. It could be a sort of a transient correction. There is people like James Hansen who have speculated that this is actually not a transient event, that this is a long-term acceleration leading to faster global warming. I would say we can't say for sure which version of that story is correct. I generally lean in the direction of this being more of a transient change rather than a long-term acceleration, but we will see. Either way, we are rapidly addressing key thresholds. We're above 1.4 C now in the long-term average. We will expect to cross 1.5 C, which is the sort of lower Paris Agreement target before the end of this decade, or possibly just after the turn of the decade. But it is coming very soon that we will cross 1.5 C, and we are continuing a rapid upward trajectory that will move well beyond that in the next couple decades. All right. So the full report, including other graphics and a considerable amount of additional information, is available online. And the next briefing beyond this will be in February of 2026, looking at January temperature patterns.